Okay, good afternoon. So last week we talked about a Unity interface and talked about some built-in methods like awake, start, update, late update, fix update, and some components, for example, transform component. And we create some 3D objects, could be cube and plane or something else. Today we are going to continue Unity again, so we will not make any kind of game this week. So this is week 2, there must be week 3 also here. Okay, awake, start, and let's just remember, awake is used to initialize any variable or game state before the game start. Okay, it is called before the game start. And after that, start method is called. Like the awake method, start is called exactly one time. Again, okay, awake is called one single time. And awake is called when the script is initialized regardless of whether or not script is enabled. Okay, even if the script is disabled, awake is called. We told you right last week. But in order to call this start method, or in order to let Unity use to call this start method, you have to enable the script. So the script should be active. That means the script is not active. This means is active, right? Enable or disable. Kayıt bu arada devam ediyor değil mi? Sıkıntı olmasın. So, and let's continue here again. And after that we had update methods. Update is called every frame as the game runs. Every frame means the update is called around 50 times per second. So, but it depends. Last week we showed it, like sometimes 40, sometimes 60, it depends. So it will continuously repeat until someone stops the game. So if you do this, you simply transform, translate 0, time delta times 1. So this is x and y and z axis. So it's going to move in z axis. This is the value of this is around 0.02. So it will move 0.02 unit per frame, which means it is going to move 1 unit per second. And in the fix update, this is called for rigid body again, because in rigid body you have to fix the frames. So frame shouldn't be like 40, 60, it all should be always same, so that you can do some physical things, some gravity, some simulation things. And this is good when all your object has a rigid body component. Yani objenizde bir rigid body bileşeni varsa, yani fiziksel bir obje ise mutlaka buradaki işlemleri, hareketleri ve diğer şeyleri fix update içerisinde yapmanız gerekiyor. Okay, this is a must. And we talk about on GUI or on GUI, that is to create dynamic buttons or text, whatever you want. But we are not going to use this that much. And we had on disable, on enable. On disable is called when you disable a script, right, or an object. And on enable is just called when you enable it. So when you do this for run your project, if you do this, that method on disable will be called, and if you do that, on enable will be called by the Unity. And then we talk about late update. We say late update is called after update and fix update. The reason is because you want to do some physical simulation, and after that you want to render it. So your camera can render the real or the true simulation. If you call your camera things before update or fix update, that will not reflect your real simulations, physical simulations. You understand the idea, right? Yani late update'te kamera işlemlerini yapıyoruz. Bunun sebebi de şu, fix update daha önce çalıştırıldığı için fix update'te ilgili fiziksel simülasyonlar yapılıyor. Mesela yer çekimidir, uygulanan gücün doğru yansıtılabilmesi için yani ilgili fizik hesabının yapılmasından sonra bunun çağrılması gerekiyor. O yüzden kamerayla alakalı işlemler late update'te yapılıyor. Tamam mı? Mesela kamera dönecekse, hareket edecekse gibi tarz şeylerde late update kullanılıyor. And then today we are going to continue. We'll talk about on collision enter, on collision exit, on collision stay. So collision is again, or collider is a component. I think we talked about it. It was a green frame around the object. So that is, for example, your cube. Let's just press F. If you remove your mesh render is just to render the mesh, the scheme. So if I disable it, you're going to see green things. that is like bounding box. That is called collider. The collider is used to make a collision, so a touch or like something like that. And then it works with rigid body. Without rigid body, it doesn't work.
Is it the same thing with the hitbox?
What box?
Hitbox.
Hitbox. I didn't hear about this. Hitbox is maybe, is it in Unity?
It's in the game.
Hitbox. Maybe is that one.
Like shooter games.
But this is that is the official name. It's Collider. Maybe you can call it. Sometimes they call it bounding box. Sometimes call it Collider. Sometimes maybe Hitbox is the same. I don't know. I don't play game that much. Maybe someone else know. Arkadaşlar Hitbox'ı bilen var mı? Tamam. Ben de bilmiyorum. Bakarız. I can check it if you want in Google, but later on now. We don't have much time for this. Okay, if I disable this, you're going to see a collider. I can change the length of this collider, size it as I wish, but it is always good to keep it as the size as the mesh of the object. Okay, so if I play the game, the cube will drop. Kamerayı biz sizde hareket ettirmiştik. Sizde değil mi kamera hareketi? Tamam, o zaman doğru kodmuş. Okay, I want to first of all disable these things. Okay, let me just remove all of them and except this one. Okay, this one, that is the camera here. So if I play the game here, you see that there will be a collision, right? It will draw, it will just crash. So if I remove that, where's my cube? Where's my cube? Here. If I remove that rigid body and try it again, no rigid body, no collision. If I just continue, there's no collision. You see, it will just go through. So rigid body is must for collision. So you see, my change didn't save by system. The system didn't save my change because it was in play mode. And play mode'da yaptığınız bir değişiklik kaydedilmiyor. Komponenti kaldırsanız dahi orada geri gelir. O yüzden dikkatli olmanız gerekiyor. So if you want to see you're in play mode or not, you can simply go here again. You just want to go preferences here and then colors. In the play mode, I want to make it a little bit like yellowish or like reddish or something here. And then if I play the game here, you see the colors change, and this is good. You can see that you're in scene mode. Anyway, this is okay. So I change the size of collider. I want to make it before, so reset it. It will be 1 by 1, but this is weird. Anyway, it should be 1, 1, 1. It's okay. So you understand the rigid body here. So now let me tell you something. You want to do something when your object first hit the surface or touch the surface, and that is an event. When you do that, there's a method called onCollisionEnter, and during your touch or your just contact, there will be called another method. There will be another method to call, which is onCollisionStay. During your stay, that will be another method. And then when you leave the surface, and there will be another method called onCollisionExit. So now I think it will be better to show you something like this here. So you come here and you just touch it, and this is first touch. It looks like first touch. You're touching it. Maybe, I don't know. I cannot see that. It's that time a method will be called by the system, which is onCollisionEnter, and one single time it will be called. So a collider need not to be exact the same shape, and onCollisionEnter is called when the collider has begun touching another collider and begun touching. And stay is called once per frame for every collider that is touching, and then exit means is called when the collider has stopped touching another collider. So I think it's better to see in demo mode here. So I want to add a script to my cube object. Simply, so add component called cube collision test. Simply just a script. because we are going to do everything using scripts. Double click it, it will open up Visual Studio or whatever you have. So we have start and update method by default, and I don't need this one for now, so I can just simply delete them. On collision, enter, and then, so I'm not going to write them one by one, but for you, if you want to understand them, you can write one by one, but it's provided by Unity. Private void on collision, enter, collision, collision. That parameter belongs to the object you're going to collide. So it's going to give you information regarding that object, the object you're going to touch. On collision, stay, and then on collision, exit. And there is another version which is on collision, enter 2D, but this is a 3D game, so everything should be 3D. So, like, if you change anything here, like this one, that is not going to be recognized by Unity because this is event handler. It's called after an event occur. And then, so let me just simply show you that debug.log, and I say touch begun, touch has been started. And then continue here. Then touch has been touching, and then touch ended, let's say. And then let's play the game again. Okay, I want to just put it up more, and then continue. What's wrong with this? It say ended. Why? There's no touch. Continue here. Okay. Okay, it has been started. Demek ki o ended öbürünkinden kalandı. Normalde dokunma bitmemiştir. Okay, you see now it's touching. Touch has been started, touching, and continue. So this is called one single time, and that is continuously called. If I just simply go and take this up and then leave it, you see touch ended. So it's called one single time. This is good when you want to do something. For example, you shoot to something, some target. You can simply reduce its health. You can just affect it somehow. Right? Yeah, exactly. You can just give damage. Right. This is good. But this can be used to apply force or something else. But we have another version which is called on trigger enter. In that method, in that kind of collider, you cannot go through the object. You just hit and then stop. If you want to go through the object, you have to use another method, like on trigger, enter, stay, exit. But beforehand, I want to just show you something here. How can we use this one? So I want to add something here. This collision is going to give you information regarding touching object. If you want to know information regarding this one, I recommend you to just go press this one, like, which is documentation, and then it will bring you there. But we don't have connection. We have, this is log, okay, this is offline. It's okay. So that can give you information regarding collider. And you can find so many things about this one. And like collider, capsule collider, character controller. You can simply write collision here. So collision. This is different, totally different. There must be information regarding this. Anyway, I didn't find it, it's okay. So I want to get the name of that object, which is plain, right? When I touch it. So how can I get this? I should use this one. For example, I can simply say debug log, let's say collision dot game object dot name. That will give me the object I'm touching. I started touch, and then I can do the same for the others and for the others during the stay. Maybe this will be enough for me because I want to show that I can get data of that object. Press the game. Wait on. Take a look at here. Touch has been started, plain. So you can get the touching object and you can just access its script or whatever, what a component attached to, so you can manipulate it. Ya basitçe şöyle arkadaşlar, bunun amacı dokunduğunuz obje hakkındaki her türlü bileşene sahip olmak ve bu bileşen hakkında işte değişiklikler yapmak. Mesela ne olabilir? Onun sağlığı vardır, dokunduğunuz kısım. Bu bir mermi olduğunu düşünün. Sağlık bilgisini alıp bunu değiştirebilirsiniz. Mesela 10 puan azaltabilirsiniz, 20 puan azaltabilirsiniz. We are going to tell you later on, but now it's okay. Just try to understand this. Collision, game object, and name. For example, I can have more information. Contact point, contacts, friction, force, some, and get contact, get hash, impulse, other, whatever you want. Rigid body, if it has rigid body component, you can get it. And then you can just apply force, for example, to rigid body. This is possible. Arkadaşlar anlaşılıyor mu bilmiyorum ama böyle kullandığım için size nasıl yansıyor bilmiyorum ama anlaşılıyor mu kısmı? Do you understand what I'm talking about? Okay, if you don't understand something, anything, please ask me. Okay, if you don't ask me anything, I cannot understand, you understand or not. So please ask me. So this is for that purpose. Let's say I want to go through the object. I want to just pass through the object. I don't want to touch it. Because sometimes, for example, you have a automatic door which has a relatively big collider. When you come close to the object or the door, you want to automatically open up the door, right? For this, you have to use different method, because if you use collider, you are going to hit and the door will never open. So you have to do something different. You have to use a collider, but you want to go inside the collider. So to do that, you have to use on trigger enter stay exit here. On trigger enter, on trigger stay, on trigger stay, and on trigger exit. Again, we have 2D version of them. 2D versions are for 2D programming. This is 3D. So I can just simply put it here. Like contact started, let's say, simply. And say contact, still contacting, and then contact ended here, simply. This is just to tell you whether it's working or not. But you cannot, if you play the game, you're not going to see anything, because to run them, you have to, you see, nothing happened here. This is just from the previous things. By the way, can you see them? Bunlar görülebiliyor musun tarafımızdan? Okay. Then, in order to make it work, you have to simply make this is trigger enable. Otherwise, it won't call and it won't pass through. And then play the game here. Now you're going to see that. Okay, first of all, let me just clear them. Again, start it. Take a look at it, pass through. Contact started. And then contacting. Still, let's continue here. So now contact ended. If I want to just pass through, I have to use them. You see, collision on collision enter exist and trigger exist. They cannot work together because they are separated, totally different terms. Sometimes people are confused with them, but I think you understand them, right?
What is the benefit of on target enter since it's like There is no collider.
Which one? So you mean this one?
No. I mean the trigger.
Well, both of them work with collider. If object has no collider, then it doesn't work. Object must have this collider in any case. Collider which means your object has how to say it, physical space or like volume. Otherwise, it's just an image picture. Without collider, you cannot do anything in Unity in any case, because we have in real life we have natural collider or skin is collider, but if you think about them, some holographic things, no collision at all. Without collider, you cannot interact with objects in Unity. Bakın arkadaşlar, güzel bir soru geldi. Şu collider komponenti opsiyonel değil. Zorunluluk. Eğer bir çarpışma istiyorsanız. Trigger veya değil. Ama ikisi de hem on trigger hem de on collision bu collider ile beraber çalışır. Tek farkı burada is trigger'a bir tick atmanız gerekiyor. Trigger hiç kullanmak istiyorsanız. Yoksa collider'sız hiçbirisi olmuyor. You understand the idea? Trigger'la kullanmak için tick atman gerekiyor. Trigger kullanmayacaksın. Mesela tick kaldırdım. Bu defa trigger çalışmayacak. Şu. Orada o görünmüyor. Arkadaşlar evet perdemizin problemi. Şöyle olur mu? Şu. Bak collider'ın içinde is trigger var orası. Şu. Check. Okay. Sende galiba sıkıntı var. Sen değiştir onu, değiştir. Tamam. Okay. So you understand idea. But arkadaşlar burası ciddi problem. Onu şöyle yapalım. Biraz şunu şu tarafa getireceğim. Inspect ama gelmiyor gerçi. Şöyle bir şey yapabiliriz. Şu konsolu sağ tarafa alayım ben. Konsol zaten çok önemli değil sizin için. Her sınıfta farklı yapıyoruz artık tahtanın durumuna göre. Şu an iyi mi? Daha mı iyi? En azından görebiliyorsunuz. Buradaki yazıları okuyabiliyorsunuz. Okay, then let's continue here. So that is done. Again, this is good for example, automatic things. I want to just show you an example here, simply. Very simple example. First of all, let's make this plane. Reset it, and then put it here, and then make it scale. Just go up. I think that will be enough for me. So I just want to put it up. And then I want to set my camera view like this. So this is scene view, right? And the game view is this one. I want to set the camera view in the scene menu here. Just go game object and say align with view. So now I can have that look. This is quite good for me. But maybe you don't have to use it. The thing is, I want to put another cube, 3D object, cube. That will be my door. Right, this is my door. So for this door, I want to simply put this one and make it a little bit like this, bigger. And then I want to activate is trigger enabled so that it will, well, maybe this is not important for this because in cube I already have it. In that cube I already have it. I have my trigger, okay. And then let's make it just like this. So I want to just come around and use trigger and then move this door up. Okay, it will be automatic door for me. You understand the idea? So to do this, I have to simply add something here. So simply I need to have transform component of that object so I can manipulate it, right? Because I'm going to move it up. I have to access because this is the transform component. I'm going to do something like this. But to do that, I have to access transform component of that door object. Let's call this door. So in my cube, this is attached to my cube. So let's say public and transform, then say door. If I make it public, it will be visible here. This is my cube, that is my cube, right? Okay. You see, the door is visible here. So I can simply attach this one. Now I have access to the transform component of the door object. So I'm going to simply do this one. If it enter, say, door, then translate, then say vector translation. I didn't talk about vector, I will talk about, but this will be a very simple example, vector 3 and then up. This means 0, 0, 0, 1, 0, so in y direction. So let's just see what's going to happen. Çok yakın gerçi de direkt zıplayabilir. Arkadaşlar hata yaptım. Şu big şundaki şu ya nasıl yapalım? Şu gravity'yi durduralım bir. Gravity olmasın. Kapanın da trigger'ına şu an gerek yok. Okay. Zaten şu anda içinde herhalde. Kapının şeyi yok, rigid body'si yok, unutmuşuz. Let me add rigid body to the door, otherwise it won't work, you know. And I don't want to use gravity, so it won't just go down. You see, like it's. Abi bu hala hareket ediyor, şey olduğu için. What's the problem with it? It should stop. It didn't stop it. Let's just put it here and see what's happening. Niye böyle gidiyor? Niye kendi kendine yukarı gidiyor? Sorry? Well, yes, there's a... Okay, you're right. I should do this, or I should... It's totally okay, but I think this will be enough for trigger. One of them will be enough. You don't have to make both of them. Okay, let's just run this and see. So what's happening here? It doesn't work.
He means that you write the code on collision, not in trigger.
Ah, sorry. Yep, you're right. Sorry, I made a mistake. Pardon. I made a mistake. I should put it in trigger because I don't care about the collision here. So let's just play the game here again. Because now it compiles it again, run it, and see what's happening. Okay, you see it's working. The purpose of this is like this. Understand the idea, and again, and again, and again. So now no collision, so it won't. So do it again here. You understand the idea. This is just a simple example. So, okay, I made a mistake because I had to put it on trigger enter, not on collision enter. So, okay, let's just continue. You understand this one collision trigger. This is done. So now let's talk about game mathematics a little bit. We'll talk about vectors. What are vectors? What is position? What is like translation, rotation? What do you understand when we say magnitude and then direction and dot product, cross product? Have you ever heard about dot product? Dot product, you know it? What does it mean? So, well, that's true, but the purpose of them is, first of all, you want to get the direction of a vector respect to another one, and plus you want to get if you want to get angle between two vectors, you have to use this dot product again, right? So you understand, if you want to get the angle between two vectors, like this, like this, for example, here we have two vectors, and you want to get angle between them, you have to use dot product. So, but first of all, let's talk about what is vector and what is a point in Unity. Okay, what's a vector? What's the definition of a vector? I think you must see it in high school or in the first class of your physics or something, I don't know. What is a vector? Exactly. Something has a magnitude and a direction. That is called vector. Good. That is a vector. But in Unity, we use the vector for two things. One is for location, so XYZ, which is position, and the other is one for the direction. For both of them, we use vectors, and let me tell you the difference between them. So, I don't want to use that code, and I want to just delete them all, or just simply deactivate, and then set a camera which is, sorry, I just want to look at, which is, okay, this is good, X and Y, and then say, go to camera and say align with view. The camera will be something like this. So I want to simply put empty object, because empty object means nothing. It only has a point like location and rotation and scale. So say 0.1, and then duplicate it, Control D, 0.2 here. So for the 0.1 and 0.2, I want to put simply icon. This is blue for 0.1 and then red for 0.2. So 0.1 and 0.2 here. I think this is quite good. You can make it, if I want to make it bigger, so it will be bigger here. It's activated gizmos, I can see them. Kamera biraz fazla uzakmış. Simply make it like this one, much better here. So they are, okay, make it reset. Okay, so alakası yerlere koymuşum, sorry for this. I want to reset everything to the origin so I can better see all the things, what's happening here. This is a bit tough, but it's okay. So this is quite good for me. Like this, and then maybe much better to put the camera here. This is good. So I want to present the position, or I want to present the 0.1 as a vector here. So how can I do that? Simply let's create an empty object which could be used for say vector helper. Okay, I simply create an empty object to attach script. So the object is enabled, then I can run my script. This is the only reason why I create this object. I could attach the script to camera, but I don't want it. This is complicated here. But simply create an empty object and put, say, vector helper method class. So I just want to simply get the transform of these two objects and create a vector, and then it will start from 0, the origin, to that point of each of them. And then here, I don't need this anymore, and this one. So double click it, and then here, say public transform, then say 0.1 transform, and then 0.2 transform. And then I also want to have, say, public vector3, then this will store the x, y, and z of the objects, 0.1 and 0.2. If you wait for Unity to compile, you see we have these attributes, 0.1 transform, 0.2 transform. So this is 0.1, it will get the transform component, and that is get the transform component of the 0.2. Okay, these things are necessary to be public because we're going to assign them in the script part. You can directly give this value, but this is, again, you don't have to make it because there's a system you can automatically make it. Let's make this private, so, or default. it will be invisible here. So simply say P1 is equal to 0.1 transform, and this is transform component, which is this one, that component. I want to get the position, so simply position. Understand? And then say P2 0.2 transform dot position. So it will store the position. And in the update, I want to simply draw them. So we have debug draw line, just like lock. We can draw them. So debug draw line, and say starting point, which will be vector 3 and then 0. And 0 means origin. So if you just click it and say shorthand for writing vector 3 0 0 0. So you can do this simply. New vector 3 0 0 0. It will be exactly the same. And then we want to draw a line from origin to the point 1. So the end will be point 1. Point 1. P1. Let's just call it point 1 will be much better. Point 1 and point 2. That will be point 2, so I can say point 1. And then I can think I have more parameter for color, so make it red. So we can see the color better. I want to create one more. This will be for point 2, and then make it green. Okay, can I ask you, why did I put them in update method? Because I want to continuously draw these, right, the vectors. So if I play this one, and you see, I have them. So I have this something. What if I move them? What's going to happen? Nothing. Why? Yes, because we set the position in the start method. So if you do any change, if you make any change, that will. So start is called before, like in the starting of the game. Even if you do some change, it will not consider this one, right? So if I want to make it dynamically changing things, I have to put it here. So it will always store the position. It will always store the latest position of the point 1 and point 2, because it's going to check it frame by frame. You understand? Okay. Then start it. And then take a look at here and this one. That is origin, by the way, 0 0 0. I can simply show you it is origin and then create empty, then reset them. So it will set it in origin. So let's make it something like this. Or this one. This is big. Make it like this. So call this origin. So, and then run it again. So you see, it's changing. So you understand the idea. This is the first vector, and that is the second vector, point 1. And this is going to be the direction of this. So it's from origin to here, and that is from origin to here. So what if I add these two vectors to each other? What do you expect in physics? So this is the first vector, and this is the second vector. What do you expect? So I'm going to add this to beginning of this one. So it must create a vector like this, right? So here, take a look at. That is one vector, that is two vector. I should simply add this here, and that will be my result. So x plus y, sorry, say call this A, and then call this B. That is B, A plus B. This is what I expect, right? Okay, what if my B is like this? Okay, this is the result. So it's same, right? This is my normal things. What I do, put it here. So I must get something like this in my example. So let's do it. I want to draw a new line. That will be, and again, this is short for this is 0, totally same. And then they're same. Anyway, so I should say 0.1 plus 0.2. And then make it maybe cyan, so we can better see it. Oh, compile ediyor, bilmiyordum bunu. Durmadan compile etti ya, awesome. Okay, let's go back to, you see, now it is creating that that vector. So 0.1, 0.2, so this is from 0 to here and 0 to here. If you add it here, it will create this one. So you can simply check this. So you understand how you call it. What if I do that? Minus. So minus means simply, if B is this one, minus B will be simply that one, right? That will be minus B here. And then A minus B will be something like this. Then it will be it will go here, and then it should be something like this, because it is adding A plus minus B. Yani A artı eksi B olacağı için bu şekilde olması gerekiyor. So that will be A minus B. Önce teorik olarak söyleyelim, sonra kodlarını yazalım. So then let's see it. This should be magenta. Then let's run it here. So put it here again. This one here again. So that is 0.1 minus 0.2 will be like this one, and 0.1 plus 0.2 will be this one. Minus plus. So you understand the idea. Okay, good. So you know vectors. Vectors again, it has a magnitude, it has a length, and it has the direction. So how can I get the size of a vector? It is again simple. So I can say, in mathematics, how can I get the size of a vector in mathematics? I have the x component, y component, right? X square plus y square, and then get the square root. So it will give me the length. We can try this. Let's try this. So in this we have mathematic function, math, then square. Should be, I think, root, square root. This is, yes, this is square root. So 0.1. We don't need this for one single. Okay, I will show you, don't worry about this. So we have two dimension, mathematics f square, then 0.1, the x, and then plus power olması lazım, karesi olması lazım. Ben yanlış yaptım. So şimdi power, we have to use power because x square plus, so 0.1 x and then 2. We can do the same for this. Is that the usage is 3? Okay, float is 2. And y, let's call this float, say I don't know, something, some square, let's say a, right? And I need to say math f, then get the square root a, and that will be magnitude. And then debug log magnitude. Okay. Yani point 1'in karesi, point x'in karesi, y'nin karesinin karekökü şey gibi Pisagor bağıntısı aslında basitçe. This is x square plus y square. This is something like this. How can I show you this here? Maybe like this. Let's say this is my vector, and that vector has x component, and it has y component here. And they are perpendicular to each other. So this is x and that is y according to Pythagoras, maybe, or Pisagor in Turkish we say. X square and y square, it will be that one, and then root of this will give this hypotenuse. Okay, this is good, we get this one. And what do we expect here? What do you expect here? I don't know, we'll see. It's 1.2. The reason is because the y is 0. So you're going to get square and then you get the root and it will be same. So if I put it something here, you see, let's just clear this. The result has changed. So the magnitude of 0.1 is changing because I'm making it bigger. It's getting bigger, the size is changing. So that is okay. But in Unity we have simple form for this. Just debug.log. You don't need them all. Never. You only need 0.1.magnitude. Simply. Again, I have to tell you the theoretical things, but this is what you're going to use. So how can you get, let's say we want to find the unit vector. The unit vector means we want to hold the direction, but we want to get a unit of 1. Because sometimes this is useful. Let's say my vector, sometimes the size is changing, but I want to get this, the unit of 1. Ne toplantısı? Test. Neyse, tamam. Hakan Hoca sen değiştirsin şeyini. Errors. You understand the idea, right? So the unit vector is again useful because sometimes you want to get only the direction. You don't care about these the length of the size of the. This time you have to divide the vector by its magnitude, right? So you're going to get the unit vector. To do that, we can simply do this one. Simply say vector 3. Again, it is another vector. This could be normalized p.1, and then say 0.1 divide by 0.1 magnitude. If you do this, it will give you the unit vector, and we are going to draw this. Don't worry about this. Debug, then draw line. Normalized 0.1. This time I want to choose black or white. I care about this one. Şeyde silmişiz ya, pardon arkadaşlar. So I want to first of all draw the normal one, which is the real value of the vector. You see, the size never changes. Like, I mean, this is always unit vector, but that is changing. Even if I increase this, the unit vector is still same. You understand? Because the length should be 1. Bir vektör normalize edildiği zaman yönü değişmez. Sadece büyüklük 1 olur. Bu nerede kullanılır? Genelde bir yön vermek isterseniz, o vektör değişse bile o yönde belli birim mesafe eklemek isterseniz burada kullanılabilir. Yani büyüklük değişse bile yönü almak isterseniz bu şekilde kullanabilirsiniz. So you understand the idea. You see, the red is that point 1 vector, and that is the unit version of this. Again, we have simple for short for this in Unity. How can we do that? Simply say point 1 and then normalized. That's all. Same. It's going to give you the same. So, but you have to know, of course, mathematical background of this, which is very important. So now you understand this one. Do you have any question? Is it confusing? We may not use them in game, but you have to know sometimes we are going to use them. I need to give that background. Geçen yıllarda bunu en başta vermedim. Derslerde verdiğim için kavranmıyordu öğrenciler tarafından. En başta vermek o yüzden iyi olacaktır. Bu kavramları bilin, kullanın. İleride kullanacağız oyunlarda. Çünkü belli yönde göndereceğiz, işte döndüreceğiz bir şeyler. Bu şekilde kullanmamız gerekiyor. You understand the idea, I believe. Any question? No question? Good. So now let's jump to dot product. Dot product is simply it's a multiplication of two vectors, and it returns a scalar, so like float, integer, something. It is not a vector. İki vektör çarptığınız zaman scalar bir değer elde ediyorsunuz. That shows something about the direction actually. For example, let's take a look at that green direction. That direction is actually our up direction. Like regardless your rotation, it always shows the up, the global up, which means it's up, sky, right? 0, 1, 0. Değil mi? 0, 1, 0. That is the plane, like forward vector, the blue one, which is like always telling the forward direction of your plane. So that is up, that is forward. So it never changes, but you see this forward is changing. Understand the idea, right? So if you say so this dot product, that one, that will return a value. And that value depends on that angle. It will give you negative value or positive value. So that can tell you that whether your direction is like up or down. So let's say, take a look at this one, the green and the blue one. So the green is always same because it's world up vector. It's a global. But this is changing because it's heading up. And that time, your value, your angle is going to be less than 90. So like let's say 60. So the value will be 0.5. 0.5 means you're going up. And then minus means you're going down. So you have a game, you can simply know the direction of your plane in the game. Understand? So you can maybe do some balancing. For example, your plane in your game is like falling down. You can do some balance things. Simply. This is the purpose. So now let me show you this in an example. Another purpose of this dot product is to get the angle between two vectors. Let's say we have angle between two vectors A and B. I want to compute theta. Theta is same in English, right? Theta or theta is theta. Let's say just theta. Theta ile şey yapıyorum ya, cebelleşiyorum. And then you can using this formula. Do you remember that formula? A dot product B equal to magnitude of A times magnitude of B times cos theta. Of course, this theta is here in radian, not in degree. Radian degree, we know sometimes. Okay, let's just show an example here, simply. So we have point 1 and point 2. I want to dot product them and see what's happening here. Sorry, I don't care about this. Then here. So simply okay, this two will be enough for me. This is again green and point 2. Just like before. Şunları biraz yukarı alalım şey görmek adına. Almayalım. Ya da azıcık kamerayı yukarı alalım. Okay, let's play the game here. This is normal. We have point 1 and point 2 simply. And then I want to dot product them and see what is the result here. So vector 3 and then say dot, just dot product of two vectors and say point 1 and then point 2. And we expect that this returns a value which is a dot product. And then say debug.log and write it. Dot product. Dot product. Then write it here and see what's happening. I want to make the same scenario exactly. So this is here and that is here, like this scenario. Okay. So the angle is 0.0 something. Let's make it totally 0. So it should be okay. So now it's 0. It's almost 0. If I put it, this is plane by the way. The plane is just climbing now. You see the value is changing. Again, it's changing and changing. So it's just showing heading top or heading up, let's say. And now it's heading down here. Take a look at its minus. You can simply read this value. You can use simple if statement. You can get whether it's just going down or up. Understand the idea? Okay. So now let's get the angle between these two vectors. How can we get this? We have a formula here. Then how can I get angle here? A çarpı B bölü eşittir A'nın büyüklüğü B'nin büyüklüğü çarpı cos theta. Teta'yı nasıl çekerim buradan? First of all, cos theta is equal to A times B divide magnitude of A and B, right? And then I have to get theta. I should use arccos, right? Arccosinus. You sometimes ask like, what is the point of this arccos? Okay, this is the real life we are going to use arccos in the game. Okay, and that is finally mathematics is useful. Finally, trigonometry functions are useful. So let's get this one. I'm going to, first of all, I'm going to do it by hand, and after that, I will let Unity do that. Okay. Seveceksin. Okay, now you're going to see that it's useful. Take a look at. I have point 1, I have point 2. I have to just, first of all, the formula is something like this. Say point 1, say dot point 2. This is, by the way, a pseudocode. Point 2 is equal to yok pseudocode, sahte, fake code. Çakma kod. So this is, and then, sorry, times by cos theta. This is the formula, right? That is the formula. I got it from here. So in order to get cos theta, I should do, say, cos theta is equal to cos theta is equal to, tell me, this divide by then this one. This should be 0.2, of course. Okay, now I have cos theta. In order to get theta, I have to say that theta is equal to arccos, and then that one. That will give it theta, right? So let's do it. Float theta is equal to mathematics matf. Matf is provided by Unity, by the way. Then arccos, then 0.1 dot product dot product. It's a vector, right? Point 1 is a vector. Sorry, I made a mistake. Vector 3 dot product of point 1 and point 2 and then again divide by point 1 magnitude and then multiply by point 2 magnitude. I made a mistake again here. And I think that's all, right? Yes, and this is theta in radian, because the formula is based on theta in radian. I should say theta in radian. And I should say here float theta is equal to theta in radian times by mathematics radian to degree. Yes, radian to degree. And now I can write it finally. Debug log and say theta. I made a mistake, sorry. Radian to degree. Niye öyle bir şey yazdım? Söylerken radian to degree dedim değil mi? Yazarken yanlış yazdık olabilir. Radian to degree. Yes, now let's just simply write it. What's going to happen? So point 2 and then point 1. I expect 90 degree now. It's almost 90. Yes, it is 90. Now it's 60 and then 30 and then finally 0. So you understand the idea. But in Unity we have simple form of this. It's very simple for this. I should say vector 3 then angle between point 1 and point 2 and that is angle, float angle. So then debug.log then angle. Fena mı? Biraz görmüş oluruz. Görmüş olursunuz. I want to write them together, the difference between them. This is what I compute, the first one. The second one is computed by Unity. That's the difference. I think there's no difference because Unity is using the same. This is Unity's formula. This is like a real formula. So this is Unity's and this is mine. You see the difference between them. Same, right? Bir yerde sadece ekstra yazdırıyor. Şunu yazmaya gerek yok. Now let's see the difference between them again. Same, right? It's same. Şöyle kırmızı kötü değil mi? Tamam. Kaldıralım ya. Gerek yok. Şöyle yapalım. Daha mı iyi oldu böyle? Okay, can you see that? Okuyabiliyor musunuz bilmiyorum ama beyaz olması. Bu arada bunu kırmızı yazabiliyorsunuz. Şöyle yapılıyor o da. Debug error olması lazım. Log error derseniz kırmızı yazıyor. Evet. You see? It's same. Şu an hata varmış gibi oluyor. Psikolojik olarak insan kötü hissediyor. So you understand the idea. So we know how to find the angle, and you know the cross dot products for this. That is all about this dot product. You want to continue or do you want to have a break? Let's have a break. We are here after 15 minutes. So the last thing we are going to talk about is that the definition of cross product. Okay, what is cross product? The cross product is it's a multiplication of vector, but this is vectoral multiplication, like A times B or A cross product B that will return another vector, not a scalar vector. and it will return another vector which is perpendicular to A and B. Yani A ve B'yi vektörel çarptığınız zaman ikisine dik olan üçüncü bir vektör. Bu demektir ki iki boyutlu anlamda, iki boyutlu uzayda anlamsız bir şey bu. Üç boyutlu uzayda anlamda. So it can be said that this is meaningless in 2D space. It is meaningful in 3D space because we have three different directions. So A and B, and then so C will be perpendicular to both of them. So this is useful when you rotate a vector along an axis and you don't know the rotation axis. That is useful. For example, this is turret of a tank and you want to rotate this from A to B. So you have to find the rotation axis, that is C. So in order to find that, you have to say A cross product B, that will give you C, and you're going to return this turret along the C. Şimdi A'dan B'ye döndürmek istiyorsunuz ya, dönme ekseni gerekiyor. Dönme ekseni nedir? Tabii ki C'dir burada. Bu C'yi veren aslında cross product'tır, bu kadar. So now let me show an example. You will better understand, I believe. Şöyle yapalım. Yukarıdan bakalım. Fark etmiyor gerçi. Çok önemli değil. Point A, point B. I want to get this cross product. Let's do it. I don't know the formula of the cross product, but I think we can use unity as one. Cross product'ın formülünü hatırlamıyorum ama let's check the cross product. That is confusing me. Not that much easy. Okay, I think this is more complicated. Let's don't use it. Let's just use unity one. It's confusing. It will take time. So let's say we have point 1 and point 1, point 2, and I want to get the cross product. So let's say vector 3, then say cross product is equal to vector 3, then cross of point 1 and then point 2. And let's draw this. And then let's make it pink. I don't have pink, right? We have red, green, let's make it blue. And then show it here. So let's take a look at here, make it bigger here so you'll better understand what's happening. Can you see that? A and B, and that is perpendicular to both of them. Maybe it's hard to see, but take a look at. Şöyle yapalım. Let's make it simple for you. Büyüklük değil. Burada büyüklük önemli değil. Burada yön verir, vektör verir. Büyüklük A ve point B'ye göre değişiyor. Biri büyüdüğü zaman öbürü de büyüyor haliyle. Anlatacağım. So now can you see that the blue axis is perpendicular to point 1 and point 2? Buradaki mavi eksenin kırmızı ve yeşile dik olduğunu görebiliyor musunuz arkadaşlar? Fark ediliyor, bakın. Bu şekilde görülüyor. So if I move it like this, you see it's changing. It's always perpendicular to A and B. Like this. Take a look at here. You see it's always, if I move this, it is always changing. Aslında bu bir anlamda bir eksen. 3 boyutlu bir x, y, z. Okey. Uzunluk bunların uzunluğuna bağlı. Formülü biraz karışık bakalım. Bilmiyorum, belki şey aslında EJK vardı, hatırlıyor musunuz fizikte? Onlarla yapılıyor. Okay, let me just cross product formula. Düzgün bir yer bulamadım ki. Ha, şu şekilde. Formülü şu arkadaşlar. x1 çarpı x2 şu. Şu formül bu. Yapalım mı? Bunu da yapalım hadi. Canını sağ olsun. Formül bulduk, formül nasıl olsa yapalım. Şunu bir alayım ben şuradan. Bu resim mi? Resim olması kötü oldu. Biz baka baka yaparız. Okay, this is vector A and this vector B, right? So AY BZ minus AZ BY and then AZ BX and plus blah blah. We can do that. Can we do that? Let's do that. Vector 3, say cross is equal to AY BZ. So 0.1 times Y and then 0.2 Z. And then minus A'yı 0.1'e çevir, B'yi 0.2'ye çevir, çorba. Şöyle yapalım mı? Olduğu gibi alalım. Sonra değiştirelim. So AYBZ, AZBY minus AZ times BY and then AZBX and by the way this is new vector 3 and say arkadaşlar ben bir yapayım, anlatayım size, olur mu? Anlatarak yazmak zor oluyor. Yapalım. Kim desem dedin. Kim dedi bunu? Çıkışta dövüyoruz. Float Z yok. Float X, Y and Z. Madem şey yaptık yapalım. And X, Y and Z. So 0.1 Y times 0.2 Z minus AZBY 0.1 Z 0.2 Y. Okay, this is the first one. And then copy it. I think we can change something here. AZBX, so this is Z, this is X, and that is XZ, X and Z, and then finally XY, YX, X, Y, and Y, X. Okay, we found the cross product. So simply put this here. It must give the same result because this is X and Y and Z. Let's see. I think it's working, right? Same. Right, same. This is the blue one, so it's perpendicular to the others. Yes. Bakın bu ikisi arasındaki derece 90 derece. Arasındaki açı. Ne yaparsanız yapın bunlar belli bir eksende 90 derece olacak birbirine. Çünkü ikisi iki farklı eksende. Şu ikisine dik olan da üçüncü eksen. So you understand the idea again. But again this is a formula. You don't have to memorize formula. Bu ders için herhangi bir formül ezberlemeniz gerekmiyor arkadaşlar. Gerekirse sınavda veririz eğer istersek. Ama herhangi bir formül ezberlememizi istemiyoruz. So this is X, Y and Z. You compute and you get this one. So That's simple. And okay, now let me just tell you where can we use this in Unity. I want to return this turret from A to B here. Like I want to rotate this turret along this C axis. To do that, I have to give that A and B so I can rotate around C. Let's just do that simply. So I know the orientation, rotation axis, right? So simply, let's put 3D object to cube here and put this in origin and say public transform and then cube. So I'm going to get this cube to rotate it. So here, vector helper, I have this cube and then drag and drop here. Then simply here tell that cube, then rotate, this one, rotate, and Euler or axis and angle. I want to rotate around that axis, so the cross axis, which is the rotation axis, and angle is like 10 degree. And then let's do it and see what's happening. I'm not sure, can you see that simply, but it is rotating cube around that axis. Arkadaşlar bilmiyorum, görülüyor mu buradan, biraz yamuk olduğu için sıkıntılı ama döndürme ekseni bu. Bak değiştiriyorum döndürme eksenini. Böyle gösterecek olursak biraz daha rahat görüneceğini ümit ediyorum. Şu eksen etrafına döndürüyor, mavi eksen etrafına döndürüyor. Tamam. It is rotating. Okay, let's make it simple. It will be much simpler than this. So this is x and y. Okay, x and y. So let's make it put them both in 0. Reset. This is 0.1 and 0.2 like this. And then put this in origin. Again, this is an origin. And now let's just do it again here. Now you better see, right? Şimdi daha rahat görüyorsunuz herhalde. Döndürme eksenini. Şöyle zenet şu mavi eksen etrafını döndüğünü görebiliyorsunuz. Şöyle. Basitçe tankı point 1 ve point 2 ekseninde olduğunu varsayarsak bakın o eksene doğru dönüyor şöyle. Onun dik olan eksen dönüyor. I know it's really hard to understand in the beginning, but if you play with Unity, you're going to understand, I believe. It is not easy, it's hard. And then we are going to use some of them in lectures later on. So please try to understand. I gave them beforehand, so you will understand them. Take your time and then try to understand. Any question here? No question? Kaç takımız var? Bir saat falan mı var? Takım var. Erken bitti o zaman devam edelim. Bir şeyler de anlatalım. Normalde konumuz bitti. Sizde biraz daha farklı anlattığım için. Okay, now I need to talk about something different. Okay, standard assets. Unity standard assets. Have you ever heard about them? Like you want to make fire, water, foam, steam, or you want to have a character, you want to have vehicle, craft things. We have standard assets in Unity. So now let me tell you. So it's better to organize your code. So it's better to create a folder, call it scripts, and then take them all and put inside. And this is a material, right? And then right click here and create materials. And then put it inside. So it's always better to put your things in folder here in Unity. So I want to show you a standard assets. Go to asset store and in order to download it, you don't have to log in. So say, but let me check standard assets here. Oh, just left it. It requires internet connection, by the way. And then I already download yesterday. So I just want to import them here simply. It's a package. It provides you environment, some prefabs regarding foam, fire, water, trees, so many things. You have so many things like materials, prefabs, and then animations, some sound files, scripts, so many things. Just import them all. It will take some time. So you can create simple game using on a script because it's already there are some ready particle things here. Again, I told you it will take time. So now let's just talk about them a little bit here. Bir önceki haftada mı? Oyuna başlamıştık direkt. Oyuna başlayacağız önümüzdeki hafta. Geçen sene raket oyunu yaptık. Raket oyunu yine yapılabilir mi? Başlangıç için yapılabilir. Zor bir oyun seçmek sıkıntı olur başlangıç için. Başlangıç için kolay bir oyun olsun istiyorum çünkü bu kolaydır. Rigid body, translate, rotate bunlar anlaşılması lazım. Sonraki aşamalarda belki Pac-Man oyunu yapabiliriz bu sene. Evet. Pac-Man'de yapay zeka da var. Diğer şeyler de var. Biraz ileri seviye kod var. Hatta Pac-Man'i yarıda bırakıp size ödev olarak verebilirim. Yani ekstra 10 puan vereceğim ya sene sonunda. Final haricinde. Dolayısıyla onu bitirmeyip size bırakabilirim gerisini. Gerçi bulursunuz. İnternette bir dünya kaynak vardır bunun için de anlamanız önemli tabii ki. O zaman Pac-Man yapmayalım. Başka bir şey yapalım. İnternet olmayan bir oyun yapalım. Ne, aklınıza bir şey geliyor mu? Yapabileceğimiz bir oyun olsun yani. Bütün yıl uğraşmayalım. Netice itibariyle işimiz oyun yapmak değil arkadaşlar. Biz akademik çalışıyoruz. Tetris de olabilir. Olabilir, yapılabilir. Onun da YouTube'da videolar var bir sürü. Kaynıyor. Tank oyunu da yok. Pac-Man yapılabilir. Bakacağız duruma göre arkadaşlar. Söz vermeyeyim. Tamamen zaman ve şeye göre değişecek. Again, I told you it will take time. This is extremely huge package. Koşma oyunu mu? Temple Run. O ikinci oyunumuz olacaktı. Biz de ona benzer bir oyun yapacağız. Sonsuz işte sahneler sürekli. Sen gittikçe yapılan bir şey olacak. Bir harita yapılacak dinamik olarak. Ona procedural ne diyecektik ona? Procedural creation of map'tı galiba. Yani aslında oyun random olarak gelişiyor. Kendi kendine oluşturuyor. Öyle bir oyun yapacağız. Yine onunla alakalı oyun save data yapacağız, load data yapacağız. Oyun kullanıcı bilgileri, elmas toplama gibi. Onu yapacağız, merak etmeyin. Ya temel bir oyunda olması gereken ne varsa onu burada anlatacağız. Sonra ikinci dönem bize sonrası yapay zekaya gireceğiz. İşte görme, botun görmesi, botun takip etmesi, botun üstüne etkileşime girmesi, saldırması gibi yapay zeka kısmına gireceğiz. Bu dersi verirken arkadaşlar bir kitap takip ediyorum. Yani kafama göre işlemiyorum konuları. Özellikle vize sonrası konularda. Bu kitabı size göstereceğim, getireceğim. O kitabı bitirdikten sonra bu dersi vermeye başladım. Önemli bir kitap. O kitabın yani o kitabı editleyen kişi de zaten Call of Duty oyununu yapanlardan bir tanesi. Yani bir adam, boş bir adam değil. Okay. Let's say I want to create a new scene or just simply delete them all. I don't need them. Let's right click here and say create. So here, create, because we are going to create game object. If you want to create game object, you have to go here all the time. In hierarchy, 3D object, say terrain. That is going to give you terrain. In Turkish, it's arazi. Okay, you have terrain, which is a big map for your game. You can make some environmental things like mountain, trees, water, lake, whatever you want. And you can put texture on it. So you see, we created terrain, and here in the inspector section, we have new component called terrain. And using this component, you can simply build a terrain. This is something about me, don't worry about this. Okay, first of all, I want to select this brush, and then it will give me to paint some texture. But to do that, I have to say edit terrain layer and create layer. This is again textures given in that standard package. So go down and choose whatever you want. I want to choose this green one. So now I want to just move a little bit down, and you see that we have this texture. The entire area is just covered by this texture. So I can simply say set height, and then maybe I can raise some terrain here. Set height, raise or lower terrain, and then choose this one. I can simply, it's not simply, what's happening? It's an error. Çok da, ya çok küçük yapmışım, görmemişim, evet. So you have something like this, and then you can build some terrains, or like this. This is totally up to you. If you think these mountains are like they're not smooth, you can smooth them, simply like smooth height, and you can choose this one and then smooth them all. You can play with them like this, and again set raise, or here you can raise them. If it's too raised, you can control shift, and then you can just again undo this operation simply. So I want to just make it like this, and then like this one. This is, I think, good. So it's good to put a lake here. Buraya bir göl yapalım. Yanında birkaç ağaç. So here, I want to choose another paint texture, and then create layer. This time it will be something like this one, and then choose this one, and I want to just draw that area. So this will be maybe much better, something like this. Or I'm not good at this, but you can try at home. It's totally safe, no problem. So yes, I'm going to add water here. So how can we add water here? It's simple. In this standard assets folder, we have so many things. We have like cameras, effects, environment, and then utility vehicles. Go to environment here, choose water, and then water, then prefabs. Prefabs is actually, it's a game object, modified game object. It's ready to use, made by someone. It's including scripts and so many things. I'm going to explain this prefab next week, don't worry about this, but this is again just example here. So just drag and drop here, and then you can simply move it like this, then scale it a bit, then suyu aşağıda mı kaldı çok? So water is here, and then okay, now I think it's good. So let me set the camera like this, and then choose the main camera and go to game object, say align with view. So now our camera is set here. I want to add something, maybe for the water. I can change something. Okay, this is, what is this? That is different. Bu su daha iyiymiş bak. That water is much better. So this one, in that water, I think I can do something reflective, simple. This is simple water. That is reflective. That is refractive. I think this is reflective is better because it's going to reflect the mountain shape. Let's play the game, see what's happening. Uzak hareket ediyor da uzak kaldığı için görünmüyor. Okay, let me just... Bu arada bu bayağı büyük bir alanmış yani. Scale'imiz biraz bozuk. Bu bayağı büyük yani. Onları da ekleyeceğim şu an birazdan. So I think we have a problem with the light. What's the problem with the light? Let me change them. Güneş var da güneş alakasız bir yerde. Let me change the orientation of sun. I can play with sun. Here, go transform. Rotate it bit. Şöyle. Güneş tepede görüyor musun? Bak şurada görüne. Yansıyor şeye. Arkadaşlar haber vermeden çıkmazsanız iyi olur dersten. Çıkabilirsiniz belki ama haber verseniz iyi olur. Bunu yapmayın. Okay. I want to change this. Say the water and make it refractive. This is better for the daytime. It's up to you again. But go to the scene. Put the camera close. Okay, make it global so you can simply go down. Let's see. Hareket ediyor, görünmüyor mu? Bayağı yaklaşayım ben ya kameraya. Şu an görünüyor mu? Okay. So you see. So let's add some trees. How can we add trees here? We have another things is paint trees and edit trees, add tree. Then in the standard assets we must have some tree. So should be here. This one. Then edit. Then go to scene mode here again. I choose my C and this is the brush. You have size, so you can put the tree here. I want to make a small area, and then for density, which means number of trees, I want to reduce this here a bit. So like put something maybe here, and then add one more maybe here, and then here. It's up to you. Maybe one more here. You can add one more tree. It's up to you totally. So it's like quite nice scene, I think. So hayalimdeki ev falan. Bir tane ev çakalım. Okay, so you can add more different kinds of tree. You can remove trees simply. For example, if I shift click, I can simply remove them all. And then control again. It's very simple. They call it speed tree. And then we can add some brush, some grass things here. So edit details, add grass texture, and then you can choose grass texture here, and then say add. So let me just add some grass here. So this one, terrain, and then grass. Where's the grass? Did I choose grass? Okay, you see, I can put some grass here. It's totally up to you. Again, this is not important for us. Maybe later on you can use them in your games, but again, we don't care about them for now. Not so important. But this is the thing, your area. You can play with this. So it's a winding here, just a moving. Okay, I want to just simply add some in standard asset. I have some scenes, sample scenes. Go to scene here, 2D character. So there are something made by Unity. You can just make a 2D platformer game, and you can modify them or whatever you want here simply. Okay, and let's change another scene. That is aircraft. Ses niye gelmiyor ya? You can play with this or this one. This is AI, and then play it play with it. It will just move automatically. You can change the camera's view. You see there are so many cameras here. This is active now. If you change it, that is active. It's very simple. You're changing cameras. So there's one camera is like behind, one camera is front. So something like this. You can have the other one. This is propeller. Tayyare. AI is better than me, by the way. I'm not good at this. Okay, this is enough for me. So you have this one, this AI, and that is car. So you have a nice car. So you can play with them. So this is AI car again. It will go automatically. You have characters. This is first person character. So you are the character here. You can just simply move, jump, and then you can jump here. And another one, this is third person character. So this is called Ethan. So simply, okay, the game is over. Then this is, I think this is AI. Yes, this is AI character. So you just put your direction, it will automatically go to there. We are going to use now mesh agent for this. It will automatically create a A-style algorithm for this and then go to there in a shortcut, using a shortcut. Okay, particle, sorry. Hazır Unity içerisinde. Hazır bir yapı. Okay, here we have explosion and fire. And then fire mobile, then dust storm, then steam, su buharı, then hose, then fireworks, you have flare. The good thing is you can use them directly in your game. You don't have to do anything, just drag and drop, that's all. I'm going to explain how we'll do that. It is very simple. So we have explosion again. You can reset it. You can just put a timer for this. So you understand the idea. For example, I want to create my own scene. Let's say create scene again, and then go there. It will be empty, and I want to use the fireworks here or explosion here. I should go to there again, and then effects. Maybe they are where they are. You can just simply say dust, for example. Now it will tell you this is the prefab. Sorry, this is prefab. Dust prefab. Choose your scene and then drag and drop. So now you will have your dust. But this is not active. Make it active. Now you will have dust here simply. You see? You just simply use it. That's all. And you can use whatever you want in your game. It is very simple, and we are going to use them in our games because we don't want to make dust. And I also I will tell you how to make them by yourself. Of course, making fire is not easy. It is easy, but you have to use some textures. You have to download something, but this is not my. That is not our subject or our purpose because we want to write codes. This is game programming. We want to program games. But I will tell you if you need. So this is the end of lecture. If you have any question, ask me. Otherwise, the lecture is over.